I'm using Scikit-Learn's LeaveOneGroupOut, a method for cross-validation that's especially useful when you have data grouped in a specific way. Imagine you're testing different medicines, and you have results for different people. LeaveOneGroupOut makes sure that the data from the test group is totally separate from the data used to train the model. This helps us avoid unfairly judging a medicine based on data we already used to create our model. We have 15 data points, which are divided into groups. This array shows how our 15 samples are organized into 4 groups. The numbers represent which group each sample belongs to. For example, the first 3 samples belong to group 1, the next 4 belong to group 2, and so on. This is crucial for LeaveOneGroupOut because it will work on these groups. Here's how LeaveOneGroupOut works step by step. First, it looks at each of the 4 groups. Then, it takes one of the groups and sets it aside as the test group, the group whose data the model will not see during training. The rest of the samples will be used to train the model. After that, it repeats the process, picking a different group to be the test set, and retraining the model with the remaining groups. It does this for every group. This helps us get a good sense of the model's generalization capabilities. LeaveOneGroupOut method iterates through each of the groups. In each iteration, one group is used as the test set to evaluate the performance of the model. The rest of the samples, excluding the test set, are used to train the model. Because there are 4 distinct groups in the data, LeaveOneGroupOut will create 4 splits. Each split will consist of a training set and a test set. In every split, only one complete group will be in the test set. The other groups will be in the training set. The training set for each split includes all samples, not in the group selected for testing. This approach prevents data leakage. Data leakage can happen if similar samples are both in training and testing data. By splitting by groups, this is avoided. I'm using the Scikit-Learn's LeaveOneGroupOut function, a technique for cross-validation that's especially handy when you have groups of related data points. It ensures that data points from the same group aren't split between training and testing sets, preventing potential bias or leakage. I have a dataset with 15 samples. Think of these as individual data points or observations. These numbers tell me how the samples are grouped. Samples 0 to 2 belong to group 1, samples 3 to 6 to group 2, and so on. This grouping is crucial for LeaveOneGroupOut because it dictates how the data will be split for training and testing. Here's the first split I'll create. I'm holding out group 1 as my test set, and the remaining groups, 2, 3, and 4, form my training set. For my second split, I'll use group 2 as the test set, and groups 1, 3, and 4 as the training set. I'm systematically leaving out one group at a time. Next, I'm selecting group 3 for testing, and the other groups, 1, 2, and 4, make up the training data. Finally, I'll use group 4 for testing and groups 1, 2, and 3 for training. I'll end up with 4 splits because I have 4 distinct groups in my data. Each split evaluates a model's performance on a unique group while learning from all other groups. This line defines the groups for each data sample. I see. We have 15 samples divided into 4 groups. 3 samples in group 1, 4 in group 2, 5 in group 3, and 3 in group 4. This grouping is crucial for the LeaveOneGroupOut cross-validation technique. This is the core question. It's asking you to think carefully about how the LeaveOneGroupOut method will split the data based on the groups we just defined. It will test your understanding of how this method works in practice. This statement is true because LeaveOneGroupOut creates one test set for each unique group. Since we have 4 unique groups, 1, 2, 3, and 4, we'll get 4 splits. This statement is also true. That's the defining characteristic of LeaveOneGroupOut. Each test set contains one whole group. Again, true. LeaveOneGroupOut ensures that the training set for a particular split never includes samples from the test group for that split. This helps prevent data leakage, a common problem in machine learning. This last statement is true because it directly addresses the benefit of using LeaveOneGroupOut. By separating groups entirely into training and testing sets, we're protecting our model evaluation from any biases or inaccuracies arising from dependencies within those groups. I'm using LeaveOneGroupOut, which is a cross-validation technique in Scikit-Learn. It's designed to handle data where samples are grouped, preventing data leakage from occurring. I'll create separate training and testing sets for each group, ensuring that samples from the same group are never split between those sets. This array tells me how the 15 samples are grouped. Notice there are 4 distinct groups: 1, 2, 3, and 4. Each number represents a different group, and the repetition indicates how many samples belong to each group. I have a dataset with 15 samples in total. The groups array helps to divide these samples into distinct groups for cross-validation purposes. Because I have 4 unique groups, 1, 2, 3, and 4, LeaveOneGroupOut will generate 4 distinct splits. Each split will hold out one group for testing and use the rest for training. That's exactly how LeaveOneGroupOut works. In each split, one complete group of samples is designated as the test set. To avoid data leakage, I'm using all samples that aren't in the test set for training. This ensures that my model doesn't peek at the test data during training. Yep, LeaveOneGroupOut is perfect for this. By keeping whole groups together, I'm preventing the problem of data leakage from causing inflated or unrealistic performance estimates. I'm using scikit-learn's LeaveOneGroupOut function. It's a technique in machine learning that helps me avoid data leakage when I have groups of similar data points. It does this by, in each iteration, leaving out one entire group for testing and using the rest for training. This is crucial because it prevents the model from seeing data in the test set during training, leading to a more realistic estimate of performance. Here's what happens in the first split. I'm testing on group 1, so all those samples go into the test set. The training set gets all the samples from groups 2, 3, and 4. In the second split, group 2 moves to the test set, while groups 1, 3, and 4 form the training set. I'm repeating the process of testing on a single group and training on the rest. For split 3, group 3 becomes my test set, and groups 1, 2, and 4 make up the training set. See how each group gets its turn in the spotlight. Test set, one at a time. Finally, in split 4, group 4 is held out for testing, and the remaining groups 1, 2, and 3 are used to train my model. It's like a fair rotation for each group, ensuring no group unfairly influences the overall model performance evaluation. I'm using scikit-learn's LeaveOneGroupOut function. It's a powerful tool for cross-validation, specifically designed to handle data where samples are grouped. Think of it as a smart way to split your data for testing and training, ensuring you don't accidentally peek at the answers before you've learned enough. This technique is super helpful when dealing with data that has dependencies between groups. This is the method I'm using to evaluate the performance of my model. LeaveOneGroupOut cross-validation is a specific type of cross-validation where I leave out one whole group of data at a time for testing, and I use all the other groups for training my model. It helps avoid data leakage issues, specifically in grouped datasets, ensuring a more reliable model evaluation. This shows how my 15 samples are organized into groups. I have 4 distinct groups. Group 1 has 3 samples, Group 2 has 4, Group 3 has 5, and Group 4 has 3. The numbers represent which group each data point belongs to. Because I have 4 unique groups, LeaveOneGroupOut will create 4 different splits of my data. In each split, one entire group will be held out as the test set. I have a total of 15 data points to work with. It's the total data points I want to split into test and training sets while avoiding data leakage. This statement is true because there are 4 unique groups, and LeaveOneGroupOut creates one test set for each group. This is also true. In each split, exactly one group is entirely in the test set for evaluation purposes. This statement is correct. The training data for any split will contain all samples except the samples in the test group for that split. This is how LeaveOneGroupOut ensures group independence during model training and evaluation. This is true. By keeping groups separate, I make sure that my model isn't accidentally learning patterns from the test set. That would be data leakage. LeaveOneGroupOut is a great way to avoid this.